Hello class, this is Michael Carr, Mr. Carr, helping you determine what and when to use normal distribution and curve. Many things you use every day in real life circumstances will have normal distributions and curves. For an example, if the health department wanted to look into the data of blood pressures, they would use it. Even if they wanted to look into the low blood pressures compared to the high blood pressures to the normal blood pressures, this would all relate to normal distribution and curve. They could also look at what percent and how many people had high blood pressure. This would help analyze the data. These four characteristics are what every normal curve will have. Every normal curve will have a mean, median, and mode. They also will be bell-shaped and symmetrical around the mean. The mean is the peak of the curve. The normal curve will never touch the x-axis, but will come closer as it gets farther away from the mean, or farther away from the biggest hill, so it flattens out as it goes by, or goes away from the mean. The total area under the curve is equal to. This is what a normal curve and distribution will look like. Say you're giving a group of data, and your mean is 94, which is the peak of the hill. They then said your standard deviation was 6. So then you have 188. So this is your first set of standard deviation. Then you have 106 and 82. So you add 6 every time you go up, and then you minus 6 every time you go down. This is what a normal curve will look like. This is an example of a normal distribution, normal curve. These are weight of pigs. The standard deviation, it doesn't say, but we can figure it out pretty easily, because it goes from 425 to 433 to 441. 425 to 433 is 8. 425 to 417 is 8. So we can write right here that our standard deviation is 8, which is pretty easy to find out. So it says what percent are above 433. So even that sounds kind of complicated, it's not really, because your calculator does all the work. You then go to second vars on your calculator, and you go to number 2, which is normal CDF. We don't use the first one, because that doesn't give us the data we need. You then you find the left bound of what you're asking for. So they're asking for what percent are above 433. That's right here. So we don't care about any of those numbers right there. We don't care about. So you do left bound, which is the farthest left you need, which is 433. You do right bound, so 433 is there, that's what number we need. We do right bound, we're just going to pick a huge number, so I chose to pick 9999. Then you do the mean, which is right here, which is 425. And then you do the standard deviation, which is 8, because we found it out. So then you type into your calculator by going to normal CDF. You type in these numbers in. You then have to do a comma after every one. Really not that complicated once you figure it out. So then we push enter, and we got about 15.8, which rounded up to 16%. So the weight of the pigs that are over 433, 16% of the pigs weigh over 433 pounds. If you remember from the last problem, we had 16% of pigs weigh over 433 pounds. And on a lot of math questions on math tests or the Algebra SOL for Algebra 2 SOL, they're going to ask you how many pigs weigh over 433 pounds. So we had 16% of pigs weigh over 433 pounds. And then it says, the problem said that you had 694 pigs. After that, it's simple math if you know what you're doing. So you have 694 pigs times 16% that weighed over 433 pounds. So that will give you 111.04 pigs, which is really 111. So just from a simple hill with a couple of numbers could help you in real life every day. This could be related to if an agricultural farm with pigs wanted to know what kind of diet they needed to go on, because some pigs were overweight, some pigs were underweight. This could help for cows and chickens and goats. It could be used for any animal. It could be used in factories. Normal curve and distribution will help you in everyday life. I hope this video has helped you learn a little bit more about normal curve and distribution.